So today we're going to begin Chapter 3 on solving systems of equations and linear system. We're going to start off by just using tables and graphs in order to solve. So our objectives, we're going to be answering the question, how do we solve systems of equations? And we're kind of be answering that all week. So we're going to solve them today using graphs and finding a point of intersection, and then also using linear system features on your graphing calculator. So first, our vocab. A system of equations is a set of two or more equations. So we're going to find a single solution or a set of solutions, or when we talk about inequalities later in the chapter, it will be a region of solutions. A linear system consists of linear equations, and a solution of the system is a set of values for the variables that makes all the equations true. Within that, we have a consistent system that has at least one solution. It could have, depending on what you're graphing, 2, 3, infinite. An inconsistent system has no solutions. So these would be like parallel lines. They never cross each other, so there is no solution. And then an independent system has exactly one solution. A dependent system has infinite solutions. So these are going to be lines that are the same. So first we're going to use a graph or a table to solve a system. So what is the solution of this system? We have two equations here, negative 3x plus 2y equals 8, and x plus 2y equals negative 8. So we're going to go ahead and graph these equations. So we're going to try and find our point of intersection. So these can be not as easily done. So let's see, for this one, my x-coordinate is, let's see, y is 0, that means x is negative 8/3, and if y is 0, if x is 0, if x is 0, then y is 4, and if y is 0, then x is negative 8/3. I'm going to go ahead and graph these. X is 4. 8/3 is almost 3. I'm going to make a line there. Okay, for my other one, if I make x be 0, y is negative 4. And if y is 0, then x is negative 8. So negative 4 on the y-axis, and negative 8 on the x-axis. Okay, well these lines should have crossed. Oh, if I extend this line here, they're going to cross somewhere way down there. Okay, so as you can see, this is not a very useful way of graphing. So go ahead and get out your graphing calculator. And then to use our graphing calculator, we need to make each one of these be y equals. So I have negative 3x plus 2y equals 8. So I'm going to add 3x, 2y equals 3x plus 8. Divide everything by 2, y equals 3/2 x plus 4, and then the other one, x plus 2y equals negative 8. It's an equal sign. Subtract x, 2y equals negative x minus 8, y equals negative 1/2 x minus 4. And then we're going to put this one into our y1, and we're going to put this one into our y2, and look and see what happens. Okay, so hopefully you can see this. So go ahead and click on your y equals. Alright, so here we go. So I'm going to go to y equals, and in y1 I'm going to put that 3 halves x plus plus 4. And then in the other one, I'm going to put that negative, oops, it should be negative 1/2 x minus 4. And then I'm going to hit graph, and we're going to watch and see where these cross. If you look at this, it looks like they should cross at about 4, -2. So it looks like they should cross at 4, -2. I'm going to go ahead and bring back that PowerPoint. So in order to check it, we can just substitute in those values, -4, -2, and see if it works. So we have to check in both. So -3 times -4 plus 2 times -2. Does that equal 8? So that's 12 minus 4, and 12 minus 4 equals 8. So it works for this one. We also have to check it over here. -4 plus 2 times -2. Does that equal -8? So we have -4 minus 4 more equals -8. -8 equals -8. So yes, they both work. So our solution is -4, -2. That's where it's true for both equations. So we can also use the table feature on our graphing calculator. So when you put those into your calculator in Y1 and Y2, then you go to view the table, and you just adjust the values until you can see where Y1 and Y2 are equal. Let me see if I can pull that up for you really quick, since I already did this. Let's see, go to, so if you go up here to table, hit second table, come on. Okay, so then we just look through these values here, and we find where our Y1 and our Y2 are the same. So you can see when we get to x is -4, both our Y1 and our Y2 values are -2. So this would be our solution, -4, -2. So there's another way you can look and see that that is our solution. Alright, so moving on, I want you to just try this one really quick. X minus 2y equals 4 and 3x plus y equals 5. See if you can find a solution using any method that makes sense to you, and check and make sure that it's correct. For this one, you should have gotten that your solution is 2, -1. So here's just one that uses a problem. So we just define our variables, and then we plug our equations in, find when they're equal to each other. So that was using a table. So when we have intersecting lines, they're going to cross at a single point. If we have coinciding lines, that means they are the same line twice, and then parallel lines. So how many solutions do we have for each one of these? Well, if we have intersecting lines, there is just one point where they intersect, so this is going to be one solution. Coinciding lines, we basically have the same lines over each other, so how many solutions do we have with those? We'll have infinite solutions. And then parallel lines, how often do they cross? They don't ever cross, so there's no solution for these. Alright, so without graphing, I want you to tell me if these are independent, dependent, or inconsistent. So in order to figure that out, we need to find the slope of each of these lines to see if they cross or not. So I'm going to go ahead and solve each one of these for y to put it in slope-intercept form. It's 2x plus 6 divided by 4. So I get y equals 1/2 x plus 3/2 for one of them. And the other one, y equals 4x minus 12. Divide everything by 8. I get y equals 1/2 x minus 6 with 3/2. Okay, so what do you notice about these lines? they are the exact same line. So these are going to be dependent lines. So they lay on top of one another. Alright, so go ahead and look at those. I'm actually going to have you do these as your lesson check with your partner. These three, I want you to say if they're independent, dependent, or inconsistent. And then your homework is 3-1, and hope you have a great day.